So our reaction has finished now. You can see that we're not making any more bubbles down here at the bottom with our magnesium. We can also see that we've captured a whole bunch of gas here. So our water line's all the way down here. Now, in order for us to figure out how much volume of gas we've captured, what we need to do is we need to look on this UDometer and we need to read the value. And so our volume of our gas that we've captured is 44.22 milliliters. So that's how much gas we produced from that sample of magnesium reacting with that hydrochloric acid. Now, before we start doing our calculations, the question we're trying to answer is, what is the mass of the magnesium that we started with? So we know that when we did that reaction, we produced a gas and that gas was captured in here. Now what I'll tell you is that gas that we produced was hydrogen gas, so H2. So our magnesium reacted to form this hydrogen gas, and what we would like to find out is what was the mass of that magnesium that we started with. Now this gas that's captured in there, it's not just the hydrogen gas. Mixed in with that is our water vapor, so we have to account for that. And then the second part of our pressure that we need to account for is there's actually some amount that goes into keeping this liquid above the rest of the solution. And so in order to find that out, I've measured the height from the ground to the top of that column and the height from the ground to the top of the solution. So that ground to the solution is 7.98 centimeters, and the ground to the top of that column is 21.08 centimeters. And so now we can use that to find the height of that acid column. We just need to subtract those two values. There's a conversion in the handout that converts that acid column, its height in centimeters, into a certain amount of pressure that's required to keep it up there. So now we can take our total pressure, which was the atmospheric pressure, this 763.5. We can adjust it with the aqueous pressure, which is what the water vapor at that temperature is related to. And we can subtract from that total pressure the pressure related to the height of that acid column, which we find by looking at the difference between these two. Once we've done all of that, now we can use the volume of our gas that we found. We can use the temperature that it was at. You can use the pressure of just the gas, so that's after we've done all those corrections, and we can find our N, our moles of our magnesium, or of our hydrogen gas, and then we can use that to find our moles of magnesium, and then we can backtrack that out to our mass, and we can answer the question, what is the mass of the magnesium? Okay, I want you to go ahead and try that. You do have all the pieces where you guys would be able to do that on your own. And then there'll be a follow-up video that I'll release next week where we will talk about, we'll walk through those calculations. Good luck.